For the nitrile groups, how to name these nitrile groups? So we have 3 carbon atoms excluding the nitrile, but when we name them, we have to include this also in a carbon chain, and this is our first carbon always. So there are 4 carbon, that's why it is but. They have a single bond N, but this time we write full ANE because it is not starting with a vowel. The functional group suffix is not starting with a vowel, and then for C triple bonded with N, we call that as nitrile. But it also may contain another group, but we always give priority to nitrile. As we discussed, first is carboxylic acid, then its derivatives, then nitrile groups are there. When we select the longest carbon chain in this example, 1, 2, 3 or 1, 2, 3. So both ways we have 3 carbon atoms. Second position we have OH group, and second position we have hydroxy. So 2 are there. So whenever 2 branches are there, then you always name the branches according to their alphabetical order. So hydroxy is first. It's not about position. It can be the one which is coming afterwards may have a closer position to the functional group, but when we name the branches, it is always according to alphabetical order. So it is 2 hydroxy, 2 methyl, because second position we have hydroxy and second position we have methyl. Prop because of 3 carbon atoms, ANE because of single bond throughout the between the carbon atoms, and nitrile due to this function group carbon triple bonded with N. Then carboxylic acid derivatives such as, like example, esters. Esters are formed when carboxylic acid react with alcohol. So the part which is attached with oxygen is considered as a branch, and it is always coming from alcohol. And the part which is attached with the main carbon C double bonded with O is considered as a chain. So 1 carbon in the branch, that's why it is methyl. 3 carbon in the chain, prop, single bond N, and due to the functional group, it is OH. So it is methyl propanoate. How to name acyl chlorides? Because acyl chloride means C double bonded with O, and Cl is acyl chloride, and the name should have oil chloride. So 2 carbon eth, single bond N, and because functional group, the suffix of the functional group is starting with a vowel, so we remove E, and that's why it is oil chloride. But if there are branches, like when we select the carbon chain, this is the chlorine, so 1, 2, and 3 carbon. So this is a branch. Second position, we have a branch, that's why 2 methyl, prop because of 3 carbon, and single bond and oil chloride, so 2 methyl propanoyl chloride. Now C double bonded with O and Cl, C double bonded with O and Cl, and between them 3 carbon atoms are there because CH3 and CH2 in a bracket 3. So you have to include all of them. So pent because of 5. Why pent? Because 1, 2, 3, 4, and then 5. A and E. Why A and E? Because when we say di or tri or tetra, we write the full A and E. We do not remove E from AN. So it is pentane, dioxide, and chloride because of this functional group. When there is amide, amide means C double bonded with O and N. 2 carbon at single bond N and amide. But if more carbon chains are attached, like hydrogen are replaced by more alkyl groups, carbon chains, then these carbon chains are considered as a branch. But how you mention these carbon chains, you will use the term N. Like what N represent, this N represent that this is an alkyl group attached directly to nitrogen. So N, one carbon means there's a branch attached to nitrogen directly, and this is a main chain. So N, because one carbon in the branch, so it is methyl, and three carbon in the main chain, so prop and amide. Now, as you can see, there are two carbon chains are attached to nitrogen, and identical are there. So NN, because first branch is also attached to nitrogen, second is also, so NN. And when you check the whole structure, like this is a main chain, so there is a branch to the main chain as well, and there are two branches attached directly to nitrogen. So N, N, and 2. Why this 2? Because 1, 2, and 3. So N and 2, trimethyl, because three branches, so that's why it's trimethyl propane amide. Same in this case. So NN dimethyl propane amide. But it can be like C2H5, then it will be, you will always name according to the alphabetical order. If it's like one of the group is ethyl, another one is methyl. So ethyl should be first and methyl should be afterwards. So it will be N-ethyl, N-methyl, and then propanamide. Like if I simply change it, instead of it is CH3, it is C2H5. Now what happened? The name will change. How the name will change, because the one which is attached with the nitrogen is a branch. So N methyl group is also a branch, and ethyl is also a branch. So which one we should name first? Because we name according to the alphabetical order. So N ethyl is there, then N methyl, and then this is a main chain. So it is prop, single bond between them, AN, and amine group is there. That amide group is there. That's why we call amide. So N-ethyl, N-methyl amide, or N-ethyl methyl amide. Is it clear how to name acyl chlorides and amides, and what is the amide function group? Then isomers, isomerism, when compound have same molecular formula but they have different structures, we call them as isomers. It can be a structural isomerism, it can be chain isomerism. Like structural isomerism is divided into chain isomerism, position, and functional group. And then stereoisomerism is geometrical or optical. So when compound have same molecular formula but different structure, we call that a structure isomerism, and it can be chain. So in chain isomerism, what happens? They have same molecular formula but different carbon skeleton, like arrangement of the carbon is different. You can see 5 carbon in a straight chain, 4 in a straight, 1 is a branch, 3 in a straight, and 2 of them are branch. So all have the same molecular formula, but they all have different names. 5 carbon, that's why it is pentane. Second position, we have a branch to 2-methyl butane. Second position, we have 2 branches, so 2,2-dimethyl propane. Position isomerism means when the position of the functional group is different. Like example, bromine is attached with the first carbon, and bromine is attached to a second carbon. So 2 different positions of the bromine, we call that as position isomerism. But functional group isomerism means the two compounds have different functional group. Same molecular formula, but different functional group. Like example, when we write ethanol, how many carbon? Two carbon atoms are there, six hydrogen are there, and one oxygen. Another compound which is called ether, this is methoxy methane. Ethers, about the ethers, you're not studying anything, but this is another organic compound, functional group when oxygen is linking the carbon chain, that's called ether. So it is, the name of this compound is methoxymethane. But you can see here, when I count the number of the carbon atoms, C2H6O and C2H6O. So what we call, when two compounds have the same molecular formula but different functional group, we call that as functional group isomerism. Same way, like example, cyclohexane. When we write cyclohexane, it is C6NH12. When we write the formula for hexene, C6H12. So both have the same molecular formula but totally different functional group. One is having all throughout the chain carbon-carbon single bond, where other one is having carbon-carbon double bond. So we call this as functional group isomerism. Then another type of isomerism, which is known as stereoisomerism, as you already studied this part, like the geometrical isomerism. So same structural formula, but different arrangement of the atoms is there. E and Z in AS, like cis and trans, or E and Z. So C double bonded with C. If the two functional groups are attached, the heavy groups basically attached to the same side of the carbon, and this arises only due to the presence of carbon-carbon double bond. How it arises? There's geometrical isomerism. Basically, carbon can form four bonds, and how the formation of a bond can occur? Two of the bond it can form in the same plane. One of the bond is into the plane, and one of the bond is out of the plane. But what happens if the carbon-carbon double bond occur, like these two are used to form a bond with another carbon? So now only possibility is left that either a molecule be in or out, and same thing for other one, the molecule will be in or out. So when we check the heavy groups, if the heavy groups are on the same side, then we call that as cis. And if heavy groups are on the opposite side, we call that as trans. So, or E or Z, you can see here when we check like C double bonded with C. So lighter groups are attached to top and heavy groups are at the bottom. So what is the name of this compound? It is, in terms of carbon number, there are 4 carbon atoms. So it is butene. But even in butene, it is further divided. So butene, it can be cis butene or trans butene, or Z butene or E butene. So in this case, because you can see the heavy groups are at the same side, so that is why it is Z butene. And if we change the position, this is also butene, no difference in the name. But heavy group, one side it stop, another side other separate arrangement out of the page. So it is E butene, or it will be trans butene. And we always give a priority to a group which is having greater mass. But if identical groups are attached, like example, if it was having like hydrogen, then it will not have any geometrical isomer. It will be same as normal, like it is propene. This is not, this cannot, because we cannot, here we can check like this one is heavy, but for other carbon we cannot say which one is heavy or lighter because both are hydrogen, so it does not have geometrical isomer. So same thing for but1-ene, there is no geometrical isomer. For but2-ene, it shows En Z isomerism. Is it clear, this geometrical isomer? Then what is optical isomer? When two molecules are actually mirror images of each other, we call that as optical isomer. And to have an optical isomer, four different carbon should be like four different functional groups should be attached, and the carbon which is having these four functional groups, that's known as a chiral carbon. So the only difference, optical isomers, they change the plane of the polarized light. Polarized light means light which is having only one plane of vibration. So when we pass through a container, example, which is having only one kind of molecule, and they are why we call them as optical isomer? Because what they do, they absorb the light and they rotate the light, the plane polarized light, either clockwise or anti-clockwise. So both possibilities are there. When light enter, it can rotate clockwise or anti-clockwise. So they are active to light or optics. That's why we call them as optical isomers. And optical isomer only occur for the molecule in which the carbon is having four different functional groups, as well as that carbon is known as the chiral carbon. So the simple way to understand is optical isomer, like example, so this is a carbon which is having bonded with W, X, Y, and Z. So if I place a mirror in front of this, so what I will see, a mirror image of this molecule. So this will be C, the Z will be here, Y, X, and W. So these two are the optical isomers of each other. The optical isomers cannot overlap on each other. Like if I move this and try to overlap, I cannot overlap. So for a compound to have an optical isomer, the carbon should have four different functional groups. So example, you can see, say you have butane 2-ol. So in case of butane 2-ol, now how to draw an optical isomer for butane 2-ol? First thing, you have to identify the chiral carbon. So how you identify chiral carbon? when you check the first carbon, this cannot be chiral because 3 hydrogen are there. The condition is that this carbon, which is a chiral carbon, should have different groups or different functional groups attached to it. When you check the second carbon, 2 hydrogen are there. When you check this carbon, look, you have OH, you have CH3, you have H, and you will consider this as 1. So you have C2H5. So this shows that this carbon is a chiral carbon. So if I want to draw the, first I will draw this carbon. So hydrogen is there, CH3, OH, and C2H5. Now if I want to draw an optical isomer, so what will be the optical isomer of this? So we have this carbon, the central carbon, hydrogen up, then CH3 closes, so it will be H3C, opposite, like, then this will be HO, and then C5, C2H5 is there, so H5, C2. So these two are the mirror images of each other, which are also known as enantiomers. Is it clear how to draw the optical isomer? So first thing is you have to find the chiral carbon and then draw that the 4 carbon like groups around that chiral carbon, then draw the mirror image. Is it clear? Any doubt in this part? And if we have sometime when we have the racemic mixture, means we have the both isomers in the same ratio, like if we have 5 molecules of the isomer which try to rotate the light polarized light clockwise, and 5 molecule for in the mixture which try to rotate the light clockwise. If we have the same ratio, we call that as a racemate or a racemic mixture. And racemic mixtures does not rotate the polarized light. Why? Because they, like, the two isomers cancel out each other, so there is no effect to the polarized light if there is a racemic mixture. If one is more than the other, yes, if it's a clockwise, the one isomer which try to rotate light clockwise is more, then it will rotate clockwise. If anti-clockwise more, it will rotate anti-clockwise. Any doubt till this point? So you can see the polarized light can be rotated clockwise or it can be rotated anti-clockwise. So next class we'll discuss the organic chemistry reactions of these aldehydes, ketones, and the separation techniques. I'll end the session and share the recording with you.